Okay, welcome to another A-level math video. Um, since the recap video for P3 was missing, I thought I should record that and complete the series that I was doing. So this is the P3 book that I use in class, and I'm going to go through all the topics one by one. This is the first volume, so this video is going to have two parts. It's a long syllabus. I generally start off teaching with the modulus function. You must have done that, the absolute valued function or the modulus function. Modulus measures the distance from the origin. You have questions that include solving either equations, or you can also have questions that relate to inequalities. So there are three different cases that you generally come up with. One is having a modulus on one side and number on the other. One is having modulus on both sides, and the third is about having modulus on one side and then an expression on the other side. Generally, it's true that you have to sort of verify your answers before you can conclude the final answer. You verify your answer by inserting them back into the original equation. But generally, you see that the answers get discarded when you have a modulus on one side and an expression on the other, and that you can see is question part B here. That is where generally answers get discarded, but that's not something that you should sort of always take for granted. Always verify your answers. That's what you need to do. Then this year, when 2020, the syllabus was changed, a new part of modulus functions was added, and that was graphing absolute valued function. So you may be asked to sketch an absolute valued function. I have a different way of teaching that. If you follow the videos, I basically remove the modulus, make up two lines, and then look for the v. And as soon as I find the v, I erase the rest of the graph, and that is my final graph. To more about this in the video, please go and watch that if you haven't already. So I drew a range of graphs. Then the real questions, you will find a lot of past paper questions on absolute valued inequalities. Again, three different cases I have here. One is having a modulus on one side and a number on the other. So I've solved that. You usually end up with quadratic inequalities. Now you probably have your own method of solving quadratic inequalities. Again, remember that your calculator can also do that. So you should always get the right answer at least once you've solved everything. If you're confused about the sign of the inequalities, go back and review quadratic inequalities, and that should help you. Um, when you have modulus on one side and an expression on the other, I generally teach that that is the only case where you have to actually verify your answers. For the other cases in absolute valued inequalities, you don't need to verify your answers. How do you verify your answer? Let's say you get these two answers. So you make sort of dotted lines and you pick up values. So I've chosen a value that's less than -3. I've chosen a value that's between -3 and 1, and I've chosen a value that's greater than 1, and then sort of verified them wherever I get a situation that's not possible. So 4 is not less than 1, so I've cancelled this out. So my answer is basically all through this region. So one of the boundaries automatically gets discarded when you select these regions. There are more questions. You can pause here, try them out if you want. I've done a few as well. Then past paper questions sometimes get challenging when you have multiple variables inside one equation or one question. So you see you have an x and you also have an a. A lot of people end up being confused because you sort of lose track of what you were trying to find. So remember that you're always looking to solve for x. So keep that objective in mind. There's no need to take an a common at this point. It's useless. What I need to do is make x the subject and solve. This can get even more challenging in questions such as this one. So you should pause here, try to solve this one on your own, see if your answer matches my answer, because at one point you have to go on and sort of do some breaking the middle term in terms of a to get to the final answer. So that's a short first chapter. Then the next chapter that I generally teach is the binomial. No, it's sorry, polynomials. Maybe I do it in a different order in class. Polynomials. This is sort of those who've done add math find this chapter relatively easy. It's also called the remainder factor theorem. Here we talk about long division and division in general, but in terms of algebra, they're no longer just numbers, but in terms of algebra, so you have an algebraic expression that's getting divided by another expression and so on. This is the basic proof of the remainder factor theorem. So if you follow the videos, you will find that we talk about remainder factor theorem in quite a lot of detail. That's just multiplication, one way of writing the equation. What I emphasize in my classes is that long division is something that you should always know on the exam. There are certain questions that will not solve without long division, particularly those questions where you're trying to find a quotient. So if you're trying to find a quotient, it's going to be difficult in some questions or impossible in some questions, where your divisor is basically not linear but quadratic. So you can have a quadratic divisor such as this one. So long division is the only division that works. So you should be aware of that. Long division is tricky. If you don't know it, please practice it before you go for your exam. Then we start talking about the remainder factor theorem. The remainder theorem says that when you plug in a value for x, so the resulting value of y is the remainder. So you use that idea to sort of solve for functions and so on, unknowns in the function and so on. And there's an entire series of questions where you get simultaneous equations and solving them. Again, when you're solving simultaneously, remember that on the P3 exam, the examiner will ask you for a method to solve the simultaneous equation. Don't just put it on a calculator and get to the final answer. That might lead to a deduction in marks. So then I have the factor theorem. The factor theorem simply says that the remainder becomes 0 or y becomes 0 when you have a certain divisor for x. Moving on. Then you have solving cubic equations. Now, over time, this idea of solving cubic equations has sort of decreased from the past papers. Why? Because your calculators are capable of solving cubic equations. That is not to say that altogether you'll have to discard the idea, but you will be asked to sometimes do show without using a calculator and so on. So you should know the process. There are 3 different ways of solving the cubic equation after the first step. The first step is always trial and error, where you try to find the first root by doing a trial and error of the factors of this number. So factors of this number are 1, 2, 3, 4, 6 and 12. So you use plus and minus, you do trial and error, and you find your first factor. For the next step, finding the other 2 factors or finding the other 2 roots, you have 3 different methods. You can do a long division, you can do a synthetic division, or what I suggest strongly is that you do a comparison. I have seen lots of people struggle with sort of polynomial questions. Why? Because they're not used to doing comparison. There are certain questions on the exam that will not solve with any other method except comparison. So you need to know your comparison, and it's important to understand how to compare, not just for this chapter, but it comes up again when you are doing complex numbers, for example. So comparison is a very useful strategy where you compare the coefficients and you sort of find the unknowns. It's like identities, but the same sort of idea applies, that you can't move to the left or right. You just have to sort of pick out the term and equate it to something on the other side of the equals to. Then there are questions, finding the other linear factor. Also left out a lot of questions. Okay. Then you also need to know cubic inequalities. There are 2 different ways of solving cubic inequalities. One is by sketching the graphs. That's something that I recommend. So you can see I have done cubic graphs at the bottom. Then I've done a basic question for you where I've sort of given you the answer and then given you the roots and then asked what values of the cubic inequality would be valid and invalid and so on. Then you also need to know graphs of power 4 curves, that they look like that. When do they look like what? That's something that you need to know. Okay, that's the end of this chapter. That's usually a 2-mark question where you have an inequality. The next chapter is binomial expansion. So with binomial expansion, again, I have a particular formula that is different from the formula sheet. I get my students to learn this formula, and it sort of then applies to all general conditions without having to take that common out and all those things if you've learned it with another method. So I generally use this idea. It's completely fine to use it on the exam as well. The examiner will not deduct your marks, although a lot of people have complained that this method is not visible in the marking scheme. You see a lot of the marking schemes for this particular topic will not have method marks. So as long as you get your terms right, you will get the marks regardless of how you've gotten them. So that works. There are some limitations to the formula that you have to make sure that x is the second term in the bracket. That's also true for the other formula that's in the formula sheet. So whichever works for you, that's how I remember the formula and how I work through it. Makes my life easier. Then there is this range of validity for any sort of binomial expansion, and that is always modulus of x is less than a over b, where a is this coefficient and b is that coefficient. You ignore the sign in the middle regardless of whether it's positive or negative. You ignore the signs of both a and b, to be honest, and that's how you get your answer. So remember this formula, it's going to help you. There is this question where x squared comes up, so remember that when it's x squared and you take a root, uh, you'll have to take a root and then sort of go with that answer. There is a recent past paper question that sort of asks you that, so if you've done the recent past papers, you would have come across that. Then again, questions start, questions, lots of them. Okay, you can stop wherever you want, try to do the expansion yourself. I've obviously left out questions. Okay, then you can also have questions that sort of have the ideas from binomial expansion from AS, and that idea is basically finding unknowns when I tell you a coefficient, or sort of finding something inside the bracket, or a particular term in terms of its coefficient only. So you can have all those ideas, but remember that all of these questions cannot be solved directly without the formula. You will always be required to apply the formula. So the formula is key, regardless of whether you're applying the formula that I've taught you or the one that's in the formula sheet. Remember your formula. So that's another chapter gone. Then you have partial fractions. Now, partial fractions is an important topic. Why is it an important topic? Because it often combines with integration. So you will at some point find partial fractions with integration, either in the past papers that you're practicing or in the exam that you will be giving. So remember that. Partial fractions are first into two broad categories. If I were to summarize it, there are proper fractions and then there are improper fractions. When you have improper fractions, that simply means that the degree of the denominator is less than the degree of the numerator, or the degree of the numerator is greater than or equals to the degree of the denominator. So in that case, when you have an improper fraction, you cannot simply start applying the cases of partial fractions that you've learned. You must have learned the cases. You cannot go on and directly apply on an improper fraction. That fraction needs to be converted into a proper fraction first, or some other method needs to be applied, and I'm going to come across an example and then I'm going to explain it to you. But if you have a proper fraction, which means that the degree of the numerator is less than the degree of the denominator. By degree, basically what I mean is that the highest power in the numerator and the highest power in the denominator. So if they're both equal, so let's say you have x squared in the numerator and x squared in the denominator, that's an improper fraction. But if you have an x in the numerator and an x squared in the denominator, that's a proper fraction. So basically for proper fractions, there are three cases. The first case is with linear expressions. That's the simplest idea that you can have. I generally tend to use the cover-up method, where I take the brackets and equate them to 0. That process, you need to know the process. That's something that you need to do and learn properly. You should be able to replicate the process, find out the numerators. Basically, you know the denominators, you need to find out the numerators. Okay. So that's another question. Another question where it wasn't factorized, so I factorized it first, broke the middle term. Okay, the one confusion here is that if it's not factorized, you're supposed to break the middle term. You're not just supposed to use a calculator and, find two values of x. Why? Because a factor is not the same as reversing the root. You might, sort of be skipping the multiples or something like that. So make sure that you do the factorization properly. Then you can have a proper fraction with repeated linear factor in the denominator. What I mean by repeated linear factor is that you could have a bracket with a whole square. So when you have a bracket with a whole square, it breaks up into 3 terms rather than 2 terms. So the repeated bracket will come once with power 1 and once with a square. Why? Because we are trying to exhaust the possibility that they could have been 2 terms. And the LCM, basically the lowest common multiple, sort of eliminated that one of those terms, because the LCM of this LCM of this and this would basically be 2x plus 3 whole square and not cube. Remember that. That's a common mistake that I've seen a lot of people do. Then if you just have a whole square in the denominator, you can break it up into two partial fractions. Then there's a third case where you have a quadratic factor in the denominator that cannot be factorized. So you have x squared plus q or x squared plus 2 or whatever the question may be. You cannot factorize this. So remember that when you are putting out the numerator, that's always, if this denominator is quadratic, then there is a linear here. If this was cubic, there would be a quadratic here and so on, but that's rarely the case. I've never seen it on your syllabus, and I think the syllabus specifically says that I think it should be a quadratic factor in the denominator, not a cubic factor. Even if it was cubic, there are a few questions like that, but they sort of get factorized. So the question tells you either in the first part, or when integrating, it automatically tells you that you have to do that, or you have to do the entire polynomials process before sort of separating the fractions. Another question, so bx plus c in the numerator. This, I think, has become more important lately, because with integration by partial fractions, you now have tan inverse as well. So this is the case where tan inverse comes into your sort of calculations when you are integrating. So remember that. Then with improper fractions, there are two ways of doing the question. One is to convert an improper fraction into a proper fraction. That can only be done with long division. Remember that. So I could essentially, sort of divide the numerator by the denominator, and, sort of convert it into a proper fraction, as I've done here. Or what I tell my students is that what you need to remember with improper fraction is that one of these constants gets separated without a denominator. How do you separate this? You just take the highest power in the numerator and the highest power in the denominator, divide them, whatever number you get is that number, and the rest of it can stay that way. I think I do a question like that here. That's where I've done this question. So I've divided 3x cubed by x cubed to get a, and then I've sort of constructed an expression, and then done that cover up method in a similar way without having to do the long division. So you can completely avoid the long division part, and you can do it directly as well. Then partial fractions gets combined with binomial expansion. Once you've separated the fractions, you can bring them up, use the binomial formula, expand each one of them, multiply them with their coefficients, and end up with a final expression. This will be, as you can see, it's a 10-mark question, 5 marks for the partial fractions, 5 marks otherwise. But to be honest, that is one of the most tedious questions to do, because those expansions take a lot of time. You make a lot of silly mistakes. So when you are doing this question, it's going to take time whether you do it at the start or at the end. I would say go with the flow. If this question comes up, do it there and then, but go a little slow there. You would certainly be exceeding the time that you are allotted for this question, but it's important to get the signs right. You see, there is very little you can mess up in terms of a concept in this question, but you can mess up a lot with just the signs. Use your calculator properly and sort of get to the final answer. Make sure that your answer also looks a little realistic. There is a common tendency to mess up the signs in this question. I mess it up myself, so I am advising you to do it very carefully when you are doing it. There are ways to check the answers such that you plug in a value for x in the final answer, and sort of plug in a value for x at this point, and you see if they balance out approximately or not. If they do, then you've done it correctly. If they don't, then you've not done it correctly. So more questions. Then there's a worksheet. Then the next chapter is exponents and logarithms. With exponents and logarithms, you need to know the rules for exponents first. I've seen a lot of people being confused with laws of exponents, though this is something that's O-level math and you should know it. Logarithms is the second part of the topic. So one primary method of solving exponential equations is to take a substitution. Remember that. A lot of you forget that, and sort of start applying random ideas, dividing and multiplying and all those things. Those don't work. When you see an exponential question, it's mostly about substitution. So that should be your first gut feeling, that I will have to take a substitution. Sometimes the substitution is provided to you in the question. If it's not, then it's your responsibility to figure out what the substitution would be. You can see in the questions on the screen, and that should help you. I've done lots of questions on substitutions. You can also have simultaneous equations, although I haven't solved this. Use the rules for indices and sort of come up with an answer. Then I can also ask you to sketch exponential functions, not just in this topic, but in another topic called numerical solutions, or iterations as we call them. So you need to know what e power x looks like, what e power x minus x looks like. Essentially, anything where x is in the power is an exponential expression. It doesn't need to be 2 power x or 2 power. It could be 2 power x. It just doesn't need to be e power x. It has an asymptote at 0 by default. E power x has an asymptote at y equals to 0, so it doesn't touch the horizontal axis, so e power x is never 0. The logarithmic function, or ln x, as we usually have it in the question, is just a reflection of e power x in the line y equals to x, so it's an inverse. There are rules for logarithms. The first thing that I generally teach is converting from the exponential form to the logarithmic form. Very important as to what becomes the power and what becomes the base. Make sure that you know your logarithms. Logarithms is a method for finding unknown powers. And I told you right now that's the inverse of exponential functions. So lots of questions on that. Then there are rules for logarithms. We're going to come across it right now. These are the laws for logarithms: addition, subtraction, and there's a power rule. So the power can climb down whenever there's a power on the number that you're taking a log of. Log is a function like sine, cos, tan. Remember that, it's there in your calculator. Make sure that you found it if you haven't seen that before, if this is the first time that you're seeing logarithms. Then often on the exam, I've seen easier questions on logarithms, not very difficult questions. And there's a natural logarithm called ln. There used to be something called lg, which was log to the base 10. That's more of an AdMath thing. I've never seen lg on your exam. Honestly, they give you a choice, and if there's a choice, just use ln. That makes things easier. Why do they focus on ln? Because I think that I don't seem to have my remote. Okay. So ln is there because integration is for ln x, and it cannot happen for lgx or log to any other base for that matter. Then solving equations using logarithms is the next idea. You have exponential equations, and then you have logarithmic equations. Again, you follow the rules. Ln's can get equated, they can get subtracted, and so on. And remember to always check your answers. So whenever you have, these are all exponential equations, by the way, and these solve with logarithms. But when you have a logarithmic equation such as this one, you always need to check your answer. What do you need to check? That the base cannot be negative, and the number that you're taking a log of, the number in front of the log, cannot be a negative number. So remember that log of -3 could not be possible. So that's something that you need to be aware of. So more questions. I'm pretty sure that you've practiced. This question, for example, combines two topics, polynomials and logarithms. Left out some word problems. Done some past paper questions. Please feel free to stop. Try to do some questions if you want. Okay, then a continuation of logarithms and exponentials is the chapter called linear law. Although it's not a separate chapter on the syllabus, I tend to separate it. This is sort of a basic tendency for someone who's done add math to study linear law separately. Linear law is the process of transforming a straight line into a curve into a straight line by changing the variables on the axis. So you see I've written ln y and ln x. What I've seen in the recent past papers is that linear law is tested more and more often. So please understand the topic, try to do it, try to understand how the axis gets changed. Once the axis gets changed, you are able to draw a straight line out of it. What is the use? It helps you in predicting sort of unknown values that are there. So let's say you have a time series graph and you have data up to a certain point and you're trying to predict the data beyond that. If it makes a straight line, you know that the straight line is going to continue, but if it would make a curve, you wouldn't know where it would turn and so on. So that's something that you need to be aware of. Okay, then all of these questions are there on linear law. This is an actual past paper question where you sort of convert into a curve into a straight line is already there, and what they are asking you is to find out unknown variables in the actual equation of the curve. So you sort of take out the gradient and the y-intercept and you sort of do the thing in reverse and you get to your final answer. This is a question that I just included from the add math. I've never seen a question where you're required to plot, but you should be able to plot. Remember that if you are doing a plotting exercise, you will end up with a line of best fit. It doesn't pass through all the points that are there. I just need to grab my remote and have some water. Okay, then the next chapter is trigonometry, which scares a lot of people. Honestly, if it were up to me, this would be the first chapter that I would teach to A2 students when they come up in August with a fresh mind. That's the topic that I would want to start off with. I've experimented with this and it sort of is a viable idea, but unfortunately with bound by school ideas, I don't get the chance to do trigonometry first. But trigonometry is an important topic. If you know your trigonometry, you will pass your P3 exam. If you don't know your trigonometry, there is a fair chance that you will fail your P3 exam, because it comes up with differentiation, it comes up with integration, it comes up with complex numbers, it comes up in differential equations. So it's nearly everywhere. So there are 7 different topics that I can point out to you where you will be stuck if you don't know your trigonometry. Trigonometry in this is tough. I basically start off with an AS revision. You should know your quadrants, rules, and so on. You should also understand the idea of negative angles. So I teach that idea separately. I have a certain set of rules for negative angles. If you don't know that, please go back, review the AS math, or I think I also explained it in the A2 video. So make sure that you understand that. That's sort of the idea of a negative angle. If you want to know what I teach, you should try to solve this question and you will understand that. Okay, then A2 trigonometry basically starts off with 3 new trigonometric ratios. Those are sec, cosec, and cotangent or cot. The ratios are in front of you. You should know them. If they're squared, if cos squared, 1 over cos squared is simply sec squared, and 1 over sine squared is cosec squared, and so on. You should be able to handle these trigonometric ratios. There are also graphs for each of these, which I explain in a later chapter. So please make sure that you watch the other part of the video as well, where I do numerical solutions, and that is where I explain the graphs, because that's generally where I see the graphs. Then the first set of identities is what we call the further trigonometric identities. The further trigonometric identities are two. They're a continuation of sine square plus cos square equals to 1. So 1 plus tan square equals to sec square, 1 plus cot square equals to cosec square. Remember that the original identity still remains, so sine square theta plus cos square theta equals to 1. Theta can be anything else. It could be 2x, it could be 3x. So sine square 3x plus cos square 3x would still equal 1. And that is true for all of these identities as well that you see on your screen. So all of these Pythagorean identities, sort of, you can change the angles. As long as the angle is consistent throughout the identity, you will that identity will stand. I solve a lot of identities in class when I'm teaching this. I get you to practice a lot as well. That's the basic identity and the basic questions here. That is where A2 trigonometry starts getting more and more complicated. The first set of formulae is compound angle formulae. Remember that these identities are also available to you in your formula sheet. They're just written in a different way. So on the formula sheet, if you see, there would be a plus minus and a plus minus here as well. For this cos identity, you would see a minus, plus minus, and a minus plus. So remember that the sign gets inverted in cos. The identities are there in front of you. I'm not recalling all of these identities, but you should be able to do them on the exam, both in terms of equations or in terms of proving identities. That is an interesting question that I've done. I've seen a lot of these questions pop up in the AS exam, never on an A2 exam, but there's no stopping the examiner from, converting sort of an AS question into an A2 question just to test. Then some more questions, solving equations and so on. You can stop, pause, do whatever question you want, compare your answers and so on. Then you have the double angle formulae. So you have three double angle formulas: sine 2a, cos 2a, and tan 2a. Sine 2a is simple, 2 sine a cos a. What I want you to understand is this identity operates in multiples. So let's say you have sine 4x, that would give you sine 2x and cos 2x here. If you have sine 6x, that's 2 sine 3x cos 3x. And remember that identities are used, and a lot of questions are in the reverse. So I would give you this and expect you to, come up with this. So you need to know that. Similarly, cos 2a is cos square a minus sine square a, and you just use that basic trigonometric identity, sine square theta plus cos square theta is 1, or cos square theta is 1 minus sine square theta. That gives you the other two identities. Again, all of these also operate in multiples. I've done one for 4x, I've not done for 6x, but that's generally true. Again, very important for integration and differentiation both. So remember these identities. So that's tan 2x and so on. I do a difficult question here. If you want to try this out, I would encourage you to do that. Again, something that I've seen in AS replicated in A2. Trigonometric identities, okay, a common mistake here generally. I've seen a lot of people do this. They take sine theta to the other side and get rid of it, or they sort of bring sine theta and cancel it out. Remember that if you do that, you lose roots, you will lose your answers, and if you lose your answers, you will not get full marks on the exam. So when you're taking a common, say that either this equals to 0 or that equals to 0. That is something that you need to do. Okay. Remember that 3 thetas don't have an identity. Don't try to apply an identity that says cos 3 theta equals to cos square 1.5 theta. 1.5 theta is useless to you. You don't have an identity there. Remember that cos 3 theta can be broken up into cos 2 theta plus theta. So you first go on and apply your compound angle identities, and then sort of support it with double angle identities as well in order to get your final answer. Okay, then you have Some more questions. To prove, you can stop and do whatever question you want. This is another question. More question. Some more questions. Okay. This, I've seen a lot of people, being confused with this. Just keep it plain and simple. If I ask you to express something in this form, there's a formula. R has the formula a square plus b square, and tan alpha is b over a. You do not need to use your compound angle formula in order to come up with this form. The form will be given to you on the exam. Usually, that's how the question is usually worded. You see the question on the board. That's sort of a replica of a past paper question. So observe what I've done in this question, and please make sure that you do this one line, two line solutions rather than spending an entire page trying to do comparisons and all those things. I don't know why students complicate this question. It's a relatively easy question. It does get complicated when you're sort of solving the angle for the angle, but this is usually a 3-mark thing, the first part, and I've seen a lot of people mess it up. But if you mess that up, you'll mess the next part up as well. So make sure that you understand what function of trigonometry is. It's called some different in different books. I've picked it up from one book and it's called function of trigonometry there. Then some more questions on function of trigonometry. I could also have cos square or something like that later on in the question. So let's say if you have 2 square, that would make it cos square and so on. Sometimes you can have different angle as well, so that changes to 2 theta. Nothing else changes. There are lots of questions like that in the past papers as well. Yeah, there you go, cos 2x and sin 2x. Remember that, hence. So it doesn't mean that you go on and apply identities. I'm pretty sure if you apply identities, you will not be able to solve this question. So try to solve it. Just pause there and try to solve it. And I'm scrolling, you can see the solution. Some more questions. Then there's this idea of having maximum and minimum values, and I've often told my students that it's best to sort of do an analysis. What I tell my students is that this cos theta plus 26.6 is a horizontal transformation. So transforming something horizontally doesn't change the maximum and the minimum values. So whenever you are doing a maximum or minimum value question, remember that you have to replace this with 3 different values. This cos can take on the value 1, it can take on the value -1, and there's another critical value called 0. 0 comes in handy when you have a square involved, otherwise it doesn't come in handy. But if you use that idea, you will be able to get the maximum and minimum values, and you will not have to worry about a lot of things. Try doing this question, the answers are there in front of you, and you should be able to get a hang of it. And your calculators can also do this for you, but they have to be programmed in a certain way. You can look at this question the way I've solved it, and you should be able to understand what's happening here. Let me know if there are any questions. More questions, homework. That brings us to the end of trigonometry. Then the next topic that I teach is where did it go? Differentiation. No, you won't be able to do differentiation if you don't know your trigonometry. Make sure that you know your trigonometry if you want to do your differentiation right. Okay, I do some AS revision, basic differentiation with tangents, normals, stationary points, and so on. That's how I teach the course. So this question as well. All of this is AS. The chain rule becomes very important when you're doing differential equations. Then the first part of differentiation is, solving for differentiating exponential and logarithmic. When I say logarithmic, it's just about ln x. You can see the rules on the board. Remember the rules. The first ones are there in your formula sheet. So y equals to e power x, and the differential is dy by dx equals to e power x. So it remains the same, and this would be given in the formula sheet. This one isn't. I have created a formula, so I just say that you multiply it with the differential of whatever is in the power. You will usually have a linear power because that's how it solves. Some more questions. Then for ln x. So the differential for ln x is 1 over x. Remember that that's not the integral, that's the differential. Then you have, if you have ln of a function, that's how the function gets differentiated. Remember that. Run some questions on the board. Minimum maximum points, you will be asked to do some bit of logarithms there as well. Then there is the product rule. The product rule basically tells you how to differentiate when you have a product of, let's say, an exponential and an algebraic expression. It could be two algebraic expressions as well. There's no stopping it as long as there's a product involved. That's how you will differentiate. U dash v plus v dash u. I've also learned it in a different way when I was taught my product rule in O-level art math. We learned it in words, so I am used to remembering it in words. How I read it is differential of the first, second as it is, differential of the second, first as it is. So I sort of differentiate in my head and, you know, sort of come up with an expression. My students have seen me do this in class. Sometimes speeds up calculation, but there's always this risk of error if you're not used to the, you know, sort of mentally doing it. Okay, then I solve a lot of questions on differentiation as well. All of these are differentiation questions. Then there's something called the quotient rule. Now, a lot of people have asked me if, you know, why don't we just, you know, get rid of the quotient rule, bring it up and you know, sort of apply the sign, apply the product rule again. Yes, you can do that. There's no such problem with doing that, but I can, you know, sort of tell you from experience that that's going to make things more complicated. So don't do that. Try to keep quotient rule as quotient rule and product rule as product rule, so that you understand, so that you can, you know, sort of simplify the expression easily. Another thing that I forgot to say when I was doing the product rule is that you'll often be asked to solve for equals to 0 or something else. Remember that it's never a wise idea to expand on the go. You can see there's something common. So let's pull that out as common and then see what happens. I can show you an example later on. You will find that something or the other is common, and that helps you solve the questions. So see this question. So show that, and bulky, this is a plugging in question. I'm going to show you something where I have equals to 0, and that's going to come up in a bit. Then you have differentiation of trigonometric functions. It's going to come up after product rule on trigonometry as well. So three trigonometric functions that get differentiated. Sin x becomes cos x becomes minus sin x, and tan x becomes sec square x. If you forget any of these, or you forget the sign of, you know, whether it's a negative or a positive, please go back and look in the formula sheet. It's there in the formula sheet, and your formula sheet is supposed to help you. It's not supposed to lie there and, you know, be wasted. If you feel there is a mistake that you're making and you're trying to recall, it's best to look at the formula sheet. Okay, then it's not necessary to have the angle as x. You can have angles as f of x. So these are all the rules in front of you. I multiply with the differential of the angle. Things can get more complicated. Let's say, where do they get complicated? I want to show you a question later on, or if I've written it here. I don't think I've written it here. I should include a question like that. Okay, solving some trigonometry questions. There. The screen gets stuck. I don't know why. Okay. Then merging logarithms and trigonometry together. This was a useful question when showing that a certain expression is this. You can also be asked to double differentiate things. Remember that that gets more complicated if you are not used to doing some complicated algebra. Things will get complicated when you're doing identities as well. So make sure that you are prepared for this. Now, these are past paper questions. For those of you who've seen me do this live, a lot of you were horrified as to how complicated it got, but that's the complexity of the exam. P3 is not an easy job. Now, you see, I was solving here, for example, for the, I had to solve here for the stationary point. So I equated this to 0. Now you see, I haven't gone on and multiplied everything out. What I've done is I've simply put this as common, and that helps me, you know, sort of simplify the question to a certain extent. I say that either this equals to 0, so this is not equals to 0 because exponentials cannot be 0. There is an asymptote there. So that's something that helps you solve the questions quickly then. More questions, you can stop, pause wherever you want, try to do the question on your own. This was an unusually tough question. This question actually, has a bit of arithmetic and geometric progressions merged into the question. If you haven't done this question, just see the year, try to do it on your own. I'm also pausing at the solution for you to see. That tells you that everything that was part of P1 can be tested in P3. So there is no stopping the examiner from, sort of asking you for volumes of integration or arithmetic and geometric progression or transformations in that case. So make sure that you know all of that. More and more questions. I don't know why this question isn't solved there. I think I've solved it on a later page. This comes up in the homework as well. Okay, then that is the end of the first part of differentiation. There are two other types of differentiation, and those are implicit and parametric. Implicit differentiation is when you have functions that are implicit. And by implicit, we mean that x and y cannot be separated. So when x and y cannot be separated, the function sort of presents a dilemma that you have to decide whether you're differentiating the x or the y. How I teach it is when I am differentiating the x term, I write a dx over dx with it, which eventually gets cancelled out. If I am separating a y, differentiating a y, I get a dy by dx. But if you, let's say, have an expression that has both x and y, remember that you have to first sort of do a product rule on this. And again, the same rules apply, that when you differentiate x, you get a dx over dx, that eventually gets removed, that becomes 1. And if you differentiate y, it becomes dy by dx. Again, this, like binomial expansion, is somewhere where you end up making very silly mistakes with plus and minus or missing out on dy by dx or something else. So do this consciously. It's not a difficult question, and always have your focus on the algebra part of the expression. Then there is often this question where I want to find the stationary points. So remember that I don't always need to make dy by dx the subject unless the question asks me to. I can just simply replace dy by dx with 0, and that sort of helps me solve it quickly. You can pause here, try to solve this question, and that should give you a hint on what I'm saying. Finding the gradients of curves at certain points. So that's another question. Then this was a question that was slightly more challenging. That's not my handwriting. One of my students was asked to do this on the board. Okay. So that's about implicit differentiation. I can ask you, okay, parallel to the y-axis means that it's a vertical line. When you have vertical lines, the gradients go to infinity. When they go to infinity, only the denominator is 0. So remember that you don't equate the dy by dx to 0, or you only take the denominator and you equate it to 0. Okay, when you are solving these implicit differentiation questions, you will often be in a dilemma as to how to solve simultaneously. So remember that the original equation always plays a role. So if you end up with getting a substitution, like for example in this case, end up getting a substitution. No, I don't end up getting a substitution here. Let me see where I get a substitution. Let me show you a question. Yeah, stationary points here. So you see I got a substitution. So whatever I used this substitution, y equals to 2x, I use this y equals to minus 2x and substitute it into the original equation, which is x squared plus xy plus y squared equals to 27. Again, conscious algebra, don't try to rush through it. You will end up making silly mistakes, and that will not help your marks. That's the second type of differentiation that you have. More complicated questions. See, I've done some homework questions as well. The last type of differentiation is parametric differentiation. In implicit, the function could not be separated. X and y was together, so you could not separate that. In parametric differentiation, the function is so separated that you can't put it together. So you don't have an equation in x and y. X is defined in terms of a parameter, y is defined in terms of another parameter. So you end up using what we call the chain rule. Everyone has a different way of doing the chain rule. I don't argue with my students. I let them use whatever way they want. This is the method that I use. I write dy by dx, and then on the right hand side I just say dy over dt over dx over dt. So that is my chain rule. I replace the values and sort of get whatever is required in the question. Again, you can have all sorts of differentiation here. You can have trigonometry, you can have exponential, you can have algebra, you can even have product rules and so on. So make sure that you know how to do your differentiation. One thing that hasn't come up is this that I want to show you. Let's say if we're differentiating y equals to sine square theta. So remember that this power comes down first, the function gets differentiated later. So first there's the power rule. You see sine theta has remained as it is, power got reduced, and then I've multiplied it by cos theta, which means that whatever was inside the bracket got differentiated. Then this is the power rule, or the rule that you learn in AS math. So that's something that you should remember. A lot of people, sort of differentiate this wrong, and that leads to terrible answers, and you should be aware of when you're getting things wrong. Some of these questions can get tough in terms of proving certain things. Again, parallel to x-axis, parallel to y-axis. I've seen more difficult questions on this. This was a particularly difficult question, I think, if I remember this correctly. And there's a small trick. If you want to pause here, pause. This is a past paper question, so that should help you. I can zoom out on the solution as well. Sometimes you have to, sort of prove this equation. So that is where the trigonometry sort of creeps in. And a lot of people get confused into how to prove, but if you do enough practice, I think you can handle this. That brings us to the end of the first part of the recap. I hope this was productive. In the second part of the recap, I'm going to continue with integration, differential equations, and then that's how the syllabus moves from there. So please like and subscribe. I will certainly post the second part of the recap tomorrow.